All right, thanks everybody for joining today. We have a continuation of a topic that we started a couple of weeks ago. We had a request from a lot of people in the community to just learn a little bit more about Zeke and how it could be deployed and how it can be integrated into your network deployments from a campus or a regional perspective. So again, we're pleased to have Fatema Bannat from ESnet give us a little bit more detail about this. And where the first talk was sort of a beginner level, this is a little bit more intermediate. And if I'm correct, I believe that this was a talk that was given at ZekeCon maybe a little bit ago, but Fatema has agreed to give it again and go over some examples about how you can use this infrastructure within your networks and learn a little bit more about what it's telling you and how it could benefit you going forward. So I will turn it over to Fatema to get started. Take it away.
Thanks so much, Jason. Good morning, everyone, and good evening, good afternoon to whichever part of the world you guys are. So just to give a background that, as Jason mentioned, that this talk is a little bit on the intermediate level of showing an implementation of a technique that that is useful basically, and how you can integrate that with the current tools like Zeke or just like a pcap reader. So jumping directly into the talk is about KYD. So a couple of years ago, like I think last year, there was a Zeke package contest that they came up with, asking community to contribute either a script or a plugin, which is useful for the other community members to implement in the Zeke. And KYD was the result of that. So we submitted a package called KYD plugin that stands for Know Your Devices. So what is Know Your Devices basically? So that package actually works primarily on fingerprinting the devices. So KYD is a DHCP fingerprinting method for detecting the end devices, operating system, or the device type based on specifically the DHCP handshake or the messages that client sends over DHCP. So a lot of times universities and other organizations who have a lot of BYOD devices, BYOD stands for Bring Your Own Device. So whenever these devices connect to your network, first of all, they need to have an IP address, right, to communicate over the internet. So what they do is they contact the local DHCP servers, and in an organization, if the organization has set up the DHCP server, which is very common, then you can actually get that data snipped. So basically, it's just like the technique that fingerprints some of the parameters that gets sent from a client, and those parameters are very specific. That tells you a lot about what the client is, and you can get an inference of what kind of device is connecting to your network or what type of device is asking for an IP address on your network. So that KYD basically gives you an impression of what kind of devices are your organization is having, or what kind of devices are connecting to your organization. It's based on, as I said, that very specific option that's called parameter list. We will get into details of what that option looks like in the DHCP message, but a lot of information gets sent out from the client side whenever it requests an IP to the DHCP server in the parameter list. So, and that sequence is very specific to the particular client or the vendor of the client. So that helps you to determine what kind of client is connecting. So that technique is based on collecting those DHCP handshakes, hashing those DHCP fingerprints, and then comparing those DHCP fingerprints to what we already know about that fingerprint. And if we see that there's a match, then what kind of device is connecting to your network. So how does this work? How does it work? So on the left-hand side, as I mentioned, that it primarily works for the organization that uses DHCP, and that not only uses DHCP, but also sniffs that traffic. So if there is kind of like east-west traffic sniffing going on, or if you monitor that traffic using one of the IDS intrusion detection system devices like Zeke, then you have ability to look into that traffic. And if you have the ability to look into that traffic, you can efficiently fingerprint that device using this technique. So a lot of devices connect to your network, they communicate over DHCP, you sniff that traffic, you capture the DHCP handshakes and then print out the DHCP fingerprint of the device in a log file that you can later on use for your monitoring purposes. So motivation, I talked about motivation briefly, that a lot of organizations do not control what kind of devices come and go on their network. And the examples include universities and some startups and the restaurants who do not have too much control over their devices and what operating system or what kind of device they support. So a lot of time it's hard it's hard basically for network administrators or the security engineers to dynamically detect the devices unless you are doing active scanning all the time, right? Like there are drawbacks of active scanning. So one way to know about all the devices on your network is keep doing the active scanning to see that, okay, what kind of inventory I have right now. But the problem with the universities and the small businesses that do not restrict the number of devices is devices come and go at any point in time on their network. So you cannot just keep scanning your network all the time. So that's why we need passive scanners like Zeke that can just sit on the network and watch the traffic. So anytime a new device comes up on the network, and if that device starts communicating, then you can capture that, or you can sniff that traffic from a passive monitoring device like Zeke. And then you can later on do any kind of analysis or investigation on the traffic that you have captured. So that was the motivation, that if you log the information pertaining to a device at that point in time, then you can later on use that extra information about the device for doing investigations or doing any kind of forensic analysis, or in general, just knowing that what your network looks like at that point in time. So, so that's one of the efforts towards building up an inventory of unconstrained devices that are connecting to an organization's network. So DHCP fingerprint theory, so the whole KYD plugin or the Know Your Devices script is based on the DHCP fingerprinting theory. And what it means is, on the left-hand side, I have shown the 4-way handshake of DHCP, that how DHCP works. So DHCP is the protocol that clients usually uses, as I mentioned, to get the IP address. So the method of fingerprinting primarily based on the packets that are sent from the client, because that's what we want to fingerprint, right? We don't want to fingerprint our servers because we already know about them. So what happens is, whenever client sends the packets, so it's a 4-way handshake. So there's a conventional discovery packet that clients send asking the server that, hey, I want an IP address to connect to the network, and whatever IP address is available out of that pool that DHCP server is serving, it offers an IP address with the subnet mask and all other parameters that client asked for in the discovery. And server sends a message back to the client in the form of the offer message. And once the client accepts the offer from the server, it sends back a request to assign or allocate that IP address to that client and take that IP address out of the available pool. So that's, again, from the client to server, there's a request for that IP address, and then the server acknowledges that, okay, I have assigned this, I have allocated this IP just for you, and this is now taken out of the pool. So this is the 4-way handshake that happens whenever a client wants to communicate over the internet or over the network. So we are interested in the packets that are sent from the client, the ones that are highlighted in the blue, so the discovery and request. So there's a speciality in these packets. What it is on the right-hand side, you can see that it's a Wireshark snippet that captures the 4-way handshake of discover, offer, request, and acknowledge. So if you look at the discover packet, it was expanded in the bottom section. And there are a lot of options that client sends, but we are interested specifically in the option 55, which is called parameter request list. And I will get to the point why we are interested in this option specifically called parameter request list. Other than the option 55, there is another option that is available in the discover and request packet, and it's option 60. And a lot of times client usually sends the information like vendor ID or what kind of specific vendor it is in that option, and that can also be captured for the DHCP fingerprint. But sometimes that option is pretty generic and might be missing in some of the client configurations. So maybe we can use it, and it's just pretty generic a lot of times. So this is the basic DHCP fingerprinting theory, that we are interested in the packets that are sent from the client because we are trying to fingerprint the client and trying to know or trying to infer what kind of operating system or vendor device is used in the client side. So we will be interested in option 55 in the four-way handshake. And that option is present in both the discovery and request packet from the client. So deep digging more into the option 55. So if you expand that, it has a lot of items that client requests from the server. And these options vary. Some options, like some clients have more than 12 options. Some clients don't even have one. I mean, they have minimum one, but the length of the parameter list varies, and the order of the list items also vary. So maybe this client is asking for the subnet mask first and the domain name server as a second option. But some clients might reverse that. Some client might ask router first and then subnet mask. So the sequence is important, and that is the basis of the DHCP fingerprints. So the DHCP request, discover request, asks for the DHCP options in a specific sequence, and different device types and operating systems request this option field in the different specific sequences. So for this client, the sequence is like 1, 6, 15. It's the sequence that we have taken. So option 55 parameter request list sends this sequence, right? So this is our fingerprint of this client. And there is a website called Fingerbank. They used to host a flat file for DHCP fingerprints database a long time ago on GitHub, and I managed to find that copy, and I have used that as a local database, a flat file for comparing the fingerprints and getting the operating system or getting the device information. Because now you might be wondering that, okay, we have the fingerprint, but what this fingerprint should be compared to, right? Because we need to have an entry that says that this fingerprint means something. So the one way is now they have created their own website called fingerbank.org. You can directly go on that website and query that fingerprint, and this output is taken from their website. So it is saying that this fingerprint for the DHCP request belongs to some Mac vendor, maybe Cisco, with a score of 50%. Like Fingerbank is 50% sure that this fingerprint belongs to the devices whose vendor is Cisco. And this is what the website looks like, Fingerbank, which is the repository. It has more than 34,000 unique DHCP fingerprints so far, and it has the user agent information as well. So this is the fingerprint that was mentioned in the previous slide. And if you query that fingerprint on their web page, it produces the results like this, that it thinks that it's a Cisco system and when it was discovered. And you can submit a combination as well. Like if you know that this combination belongs to a particular device, then you can submit it as well. You need to have an account to, the account creation is free. You can go to their website, and if you have a GitHub account, you can directly log in with your GitHub credentials and query their database. So it's free, but you just might want to create an account to query. So this was basically the fingerprinting theory of DHCP, that how you can extract or how you can infer what kind of device is connecting to your network just based on the DHCP request messages that client sends over the network. And if you have ability to sniff that messages. So a lot has been done on DHCP fingerprinting space in the past, because when I was reading the theory, I saw a lot of people talking about this is the way you fingerprinted, but it was lacking some practical implementation. I was like, now, okay, I understand the theory, but what should I do with it? Is there any kind of practical implementation that I can implement on my network and produce these fingerprints and automatically look it up on the Fingerbank or look it up in a local database file and infer the device information? I didn't find much of the implementation part. It was just theory. So what I did last year was came up with this KYD implementation that is a Zeke plugin. So how it works with Zeke. So before jumping into that, this slide shows it's a snippet taken from one of the Corelight sites. So what it is saying basically that how you can implement that theory into the practical implementation using Zeke. So this is basically Zeke architecture. It's a very high level view. There are a lot of details that are hidden right now, but it's just a basic overview to give you some information about how you can implement that. So first of all, Zeke works on the packets, right? So Zeke sniffs the packets coming out of your network, and it is fed to the event engine. So before feeding it into the event engine, there is a packet source. It can be anything. It can be a AF packet, it can be PF ring, any kind of packet source that can sniff those packets and push it to the Bro event engine. There are a lot of protocol analyzers. So the decapsulation of the complete packet happens in the event engine. So Bro starts parsing the packet. So it decapsulates the IP layer. There is a IP protocol analyzer that decapsulates that layer, and then there is a transport layer protocol analyzer that decapsulates that transport layer, and then finally application layer protocol analyzer that decapsulates the application layer. So there are a lot of protocol analyzers built into the event engine that decapsulates the complete packet coming out of your network. And what's important is the script lag. So whenever Bro starts decapsulating a packet, it generates or it produces the events. It produces the events that can be handled in the script land by the user. So if I'm looking specifically for the DHCP packets, then DHCP packets will be decapsulated and the events will be produced corresponding to the DHCP protocol. And those events, I can handle those events in the script land, and I can do whatever I want from the information that already is parsed by Zeke. And that's where the script interpreter comes and standard libraries come, and that's where the Zeke scripting language comes. So you just have to know what event gets produced whenever Zeke encounters a protocol, and you just have to handle that event in your script and do whatever you want to with that information that gets passed to the script land via that event. And then you can do all kind of different integrations with other applications like file extraction, hunting, or forensics, and etc. Okay, so this is a very this is a very basic level of what I was talking about, the event. So there is an event called DHCP message. So whenever Zeke encounters the discovery packet in the DHCP protocol, it triggers the event analyzer for DHCP, and then the DHCP protocol analyzer triggers an event or produces an event called DHCP message. You can handle that event in your script, and whatever information is extracted by Zeke from that packet, it is passed to that event. So all these fields, the connection, is origin, message, and options, these are automatically parsed data that Zeke parsed for you and gives back to you in the form of event that you can handle. So the message contains the DHCP message parsed data. Options contain all the options that is available in that DHCP message packet. So this is not just 3 lines of code. I have just highlighted some important things that to consider when you are writing a Zeke script, because you need to handle an event that you are looking for. We are looking for DHCP message. So this is the event we will be using in our script. All we want to do is all the information that is passed by Zeke. C is the connection. It is the connection tuple, which has source IP, destination IP, source port, destination port, and the unique connection ID, UID, that Zeke assigns to each unique connection. And yeah, and I think I mentioned about DHCP message and options. So all it is doing is whenever the discovery event is, whenever the discovery packet is captured by Zeke, it produces the event DHCP message that can be handled. And what we can do is we can see whether it's a discover message or not. So there was a complete rewriting of DHCP protocol analyzer in last year, and it completely rewrote all the parts of DHCP protocol. So previously, for each individual DHCP kind of packet, there was an individual event. Like for example, for DHCP discovery, there was an event called DHCP discover. For offer, there was an event called DHCP offer. But now the recent implementation of DHCP combines all the 4 types of messages into just one DHCP message. And you have to infer from the message type, message option type, that which event it is. So for example, if the message option type is 1, that means we are dealing with the discover event. So we want the discovery and request event. So that's why we are considering that if the message is discovery, then get the parameter list from the options and make a hash out of it. And once you have the hash, compare it with our local database and see if that hash is available in the database and if it is corresponding, if it corresponds to any kind of device type. And if it is found, then write a log called dhcp-fp.log file with the matched fingerprint. So this is a very high level view of what the KYD plugin does or what the KYD script does. Here is the actual implementation. So this is the script. This is the event in the script that we have handled. So this DHCP message event is this. I apologize if the font is too small to read, but the slides will be available after the talk, so you can go over the slides and ask the questions later on if you can't figure out what's going on. So this is the event handled. These are the event. These are the variables that are sent to the event handler. We are comparing that whether if it's not discovery message, then return. We don't want to process further if it is not a discovery message. But if it is a discovery message, then move along. We are attaching a DHCP FP record type to the connection already to log our fields. This is very basic parameter list parsing. So the parameter list that gets sent in the options, it is a record type, and it has like the brackets and spaces. So we are just getting rid of the brackets and spaces, and we are just kind of like sanitizing our string, and we are just making a hash, creating a hash, and we are storing that hash in the DHCP hash field that will get attached to the connection record, which will get logged. And the third module here, it is corresponding to if the hash is found in the database. So we are just comparing the hash in the DHCP-DB database. We have read that database using input framework, which is still a snippet part of the code, which is before the event, and I haven't put it here, but I will provide the source of the of this script so that you can go on and see where exactly it is getting loaded. And this is pretty easy. The hash is compared in the database, and if the hash is found, then the device type is taken from the DHCP-DB, and it is assigned to another record type, another field in the record for DHCP client. And then if it isn't found in the database, then an unknown will be written, and then the log write function is called to write the log. So this event, we have handled this event in the script land. So this is the script basically that whenever the DHCP message gets triggered, do this and log an entry in our DHCP FP log file. So I know it's pretty much technical here, but Zeke scripting language is very easy to understand. So it's very verbose. Like there are different tools out there to even find some kind of functions and find some kind of syntax to use in your scripts. Okay, so the database file that I was talking about here, that we have to compare the hash in our local database, right? Because we have the hash, but if we don't have anything, if we don't have anything to compare it with, then it's useless, right? So this database file, as I mentioned before, that Fingerbank used to have a GitHub account a long time ago where they actually posted more than 600 different kind of hashes and the device types, and they, I think, took it out, and I couldn't find it anymore because they have spun up their own website now so that you can query on their website directly, and and they know that what kind of queries people are asking for. So anyways, so this is the flat ASCII file, which is tab separated with the hash. So the database only have the fingerprint, like the parameter list options and the device type. So this hash has been created corresponding to these fingerprints, and the first column is again hash, MD5 hash. The second column is the fingerprint, and the third column is the device type or device name that Fingerbank thinks it is. And then the fourth column is the score, that how confident it is that this hash or this fingerprint belongs to a 3D printer, which is manufactured by MakerBot, or it's a Juniper network, Juno's operating system. So this is the flat file that we were comparing the hash to. And whenever there was a match, we were extracting out this information from this file and logging it into another log file. So this is what actually it looks like in the Zeke land. So if that script, the KYD script, is loaded in the Zeke cluster that you are running, then it should automatically start generating dhcp-fp.log file. So this log file looks like this. It records the 5 tuple of the connection, like the unique connection ID, the source IP, source port, destination IP, destination port, the DHCP client information that it got from the DHCP-fp database file, the hash that we calculated, and the parameter list that we extracted from the packet, like that Zeke extracted from the packet. So you have this information here in the dhcp-fp.log file. This is a pretty little better view by just showing you the IP address, corresponding operating system type or the vendor type, the hash, and the fingerprint. Okay, so now there are 2 other things that I was wondering that when I was writing the script, that what if I have a pcap and I don't have Zeke running right now, or if I have a pcap from one of the sources and I want to know what kind of operating system, what kind of devices were generating that data. So there is another script in the same package, a KYD package called KYD.py. The only prerequisite for that script is you need to install dpacket. The dpacket is the library that is used for extracting out the packet content or reading the pcap from the file. So if we are reading the pcap, then dpacket is required because that is implemented in the KYD.py to read the pcap and do the analysis on different fields and data extracted out from the pcap. And it writes down or it prints out the JSON of the 5 tuple. Like it will print out if the script encounters any kind of DHCP messages, especially the DHCP discover messages in a pcap, it will print out the corresponding hash, corresponding fingerprint, the destination IP, destination port, source IP, source port, and the timestamp. So this is the pcap implementation. So if you are not running Zeke yet, and if you still want to produce the DHCP fingerprints, and if you still want to implement DHCP fingerprinting technique, then you can do that using just one single script called KYD.py, and it will print out all the information in JSON, and then you can ingest that information in whatever tool you are using to analyze the data further. Okay, and then the third thing about the DHCP fingerprinting is, what if the hash is unknown? Like, what if Zeke is seeing some of the fingerprints that are currently not available in the DHCP-DB text file? So this is taken from the live snippet of a production environment where I have just grabbed through the unknown hashes and the unknown DHCP fingerprints corresponding to those hashes. And yeah, so if you have unknown hashes coming out of your network and there are not very many available, there are not DHCP fingerprints available in the local DHCP.text file, then what we can do is there is an integration file. So there is the third file that is available in the KYD package called dhcp-unknown.py. What that script does is it integrates with the Fingerbank. Fingerbank has an API, so all you need to do is you need to create an account to use that API, and then whenever you create an account, there is an API key that gets generated, and it is free. Like if you have a GitHub account, you can directly log in and then generate an API key for yourself, and then you can use that API key to query that API using that key. So that's all it's doing. It is you need to have the API key. You need to have your API key and the unknown hash file. And in proxy, if you're behind a proxy, then you need to provide a proxy so that you can reach out to the internet and query Fingerbank and get back the result. So the unknown hash is a pretty straightforward file. So all you need to do is you need to have the hashes and the corresponding fingerprints separated by a tab. And if you provide that file to the Python script with your API key, then if that script will query Fingerbank with all the unknown hashes, and if the combination is available in Fingerbank, or if there is a known device type that corresponds to that hash, then Fingerbank, you can get a response from Fingerbank, and that script prints out that response saying that this hash was found and this hash belongs to a switch or a wireless controller, which might be a Juniper switch with 73% confidence. And the second hash belongs to some kind of operating system. Maybe it's a Google or Android operating system. So this is the integration. So again, the DHCP unknown.py is a very simple Python script that takes the input as your unknown hash and then queries the Fingerbank database using your API key and then prints out the results that it gets back from the Fingerbank.
So we did have one question that came in, Fatema.
Sure.
Daniel wants to know, does Fingerbank have all known OS for a given fingerprint or only the high scoring ones?
It has multiple combinations. So I think if it has more than one, it shows you all the combinations on the API, but the ones that are fetched by the script is the one that is with the highest confidence.
Okay, thank you.
I think in the previous where I showed the Fingerbank one, this one, so it will show you the different, it will show you all the combinations it will have for that fingerprint or vice versa. And with it is not showing right now here the confidence level, but it shows you different combinations available for that fingerprint on the website. But I think when you're using API, it will just bring the one with the highest confidence. So any other questions, Jason?
Nope, that was it for right now.
Cool. So yeah, the scripts, KYD is available as a Zeke plugin. And as I mentioned, it was a submission for the Zeke package contest last year. So all you need to do is, if you're running Zeke, then there is a Zeke package manager called ZKG. Just like Python has pip for the package management, Zeke also has the Zeke package manager that manages the different packages available from the community in the central repository where people contribute their packages. So you install any kind of new packages available for Zeke using Zeke package manager, which is ZKG install. So this plugin is available as a Zeke package. So it can be installed using ZKG. And if you do not have ZKG, then you can directly grab that the file inside the Zeke folder and then just manually paste it in your Zeke environment and upload it. But Zeke package install is recommended way to install the packages. And the other Python scripts that I was talking about, the KYD, this handles the Zeke implementation of DHCP fingerprinting. But if you do not have Zeke running, then all you can do is there's a Python folder, and then there are other scripts called DHCP and KYD.python. KYD.python integrates with Fingerbank, so and takes the pcap as well, and then the Zeke and DHCP unknown.py also integrates with Fingerbank and then takes the unknown fingerprints and queries to the Fingerbank. And this is the flat file. It is not often updated, but it contains more than 500, I think 592 fingerprints so far. And it's a flat database file, which is, I think, available in the package under the database folder that Zeke uses. Yeah, so these are the files that are available on GitHub KYD package, and you guys can give it a try if you want to. So this was like the actual practical implementation of DHCP fingerprinting technique. So a lot has been said about DHCP fingerprinting, how you can use it with Zeke, or how you can use it on your pcap if you only have pcap, or if you only deal with pcaps and do not have Zeke. So that covers the practical implementation of the DHCP fingerprinting theory. But why you want to do that, right? Because that's the second question, that, okay, we are going through all this hassle to just implement the DHCP fingerprinting, and now we have it up and running. It is producing a log file, which is very pretty. It has all the devices that my network is seeing with kind of like a confidence level of, okay, this might be a Microsoft operating device, or this might be some other vendor ID device. But what we can do with it, right? So as I mentioned, that any information is good information. Like it's better to have some information about a device than to not have any if you're doing any kind of investigation, because it helps a lot. It filters down a lot of assumptions that you have based on what kind of forensics you are doing. So it just gives you a high level of classification. You can do any kind of other research like that. So on our network, for example, when we deployed it back in my old job, we hardly used to get 30 or 35 unknown DHCP hashes in a day. And I didn't mention that, but the free version of, I don't know whether Fingerbank has a paid version, but the free version only allows you to query 300 hashes per hour, which is quite a lot. When I started, I thought that 300 is pretty low threshold. I would easily, cross that threshold in an hour. But to my surprise, I couldn't, because I didn't. All the hashes that we were seeing on our network were already available in the local database files. So we were hardly querying like 30, 35 hashes in a day. So we were not crossing that threshold. And the good part is whenever you query the database, the script also prints out the results on the console, and it also generates another file that you can then append to your flat database file, so that you don't have to query that hash again and again. You can create a local copy in your local database. So that's another part that I didn't mention, that DHCP unknown file, a DHCP unknown Python script produces a file that you can append to your, later on you can append to your local database, so that you don't have to query back to the Fingerbank and burn one of your queries that hour. So you can get a high level view of what kind of devices you are using. We actually came up with a very pretty chart, which I don't have anymore, that actually showed the distribution of different kind of devices. And I think it was like 90% devices was Apple, and then like 10% were like Google, and then 5% were Android. So it gives you a pretty picture of your users. Like it gives you an inference that majority of your users in your organization are Apple based, or they use Apple vendor as their as their vendor, or the devices are Apple devices that are being used. So that's a pretty good information to just give as a high level, that what kind of your network topology looks like, or what kind of network device distribution looks like in your network. Uh, you can use it for the compliance purpose as well. Like if you don't comply with some certain kind of operating systems or certain kind of devices, you can get a list and see that whether the device is compliant, or if you have policies for not having certain kind of devices on your network, then you can absolutely use that kind of information to dig through that whole of security policy and compliance, and making sure that your network devices are compliant to your policies. And again, for me as a security engineer, it is always helpful to have more information regarding an endpoint when I'm doing some kind of forensics, or when I'm doing incident responding. And that at that point, I was just thinking that if only I had some more information about what kind of operating system the person is using, or what kind of vendor the person is using, then that's always great. And you can correlate that information with other kind of information or sources of information that you get out of your different kind of logs. So that's kind of like high level uses of DHCP fingerprinting. Some people might have different use cases that I would be more interested to know what they are using DHCP fingerprinting for. But that's the very general common use cases that people come up with whenever they are using DHCP fingerprinting on their network. And that's pretty much it. Thank you so much, everyone, for attending and for your time today. I hope this was useful. And that was a very basic kind of like implementation level of what else you can do with Zeke, by giving an example of implementing DHCP fingerprinting in your existing Zeke architecture. So any questions, I would be more than happy to answer if there are any questions.
Thank you, Fatema. That was great. We had one more come in, but I'll certainly put out the call to anybody else who has additional questions. Please just type them in and we'll get them answered. So Michael wants to know, is there any luck combining this data with other data sources to uniquely identify devices despite MAC address randomization in iOS 14 or Android 10? Or any concern that OS developers may soon implement anonymizing DHCP options to circumvent fingerprinting?
Okay, so that's a good question. There's always this concern, right, of collision, I have seen 5 different fingerprints belonging to the exact same device, and you can tag that okay, these 5 fingerprints belong to just Google operating system or Android operating system. So there's always this risk of collision. But if you combine the information, as the question suggests, that if you combine the information with some products that you already have that uniquely identifies operating system, then you can corroborate even better with high confidence that, okay, this operating system is a Google operating system. Zeek inherently have operating system detection, which is based on different kind of aspects, like the user agents. If a person or if a device is contacting the websites outside, or if the device is browsing, then what kind of user agents that device sends out, that information is used by Zeek inherently to fingerprint the device operating system, and that information is logged in software.log. So previously, I have always used this information and correlate that with other information that Zeek automatically produces. Like in a software.log file that I have. So pretty much everything is based on the open source and free tools that produces these logs. So there's always the chances of false positives. But if there are any kind of products that you use, like for example, active scanners, right? The one thing that I always wanted to do was, whenever we are doing active scanning, and if it is detecting some kind of, even there are some false positive, because the scanner might not be able to detect the operating system correctly. But at least if you get some kind of inference there, then you can correlate all these sources, like the sources from your active scanning, and if that scanner has ever scanned that device that you are looking at, and if that information you are centralizing it at one point in one location, and if you have different logs like software.log file that Zeke generates, that is based on the user agent field and other kind of connections that originates from the client, and then this DHCP fingerprinting. So if you collect all this information, then you can confidently say that, okay, this information corroborates to each other, and it has high confidence. But yeah, it's always there's always this chances of false positive and collisions of having fingerprinting saying it's a Google operating system, but it might not be Google operating system. But yeah, I always had experience using good experience using software.log that Zeke generates, and corroborating it with, or correlating it with, the DHCP fingerprinting that is additional part on top of Zeke fingerprinting. If that answers the question.
All right, thank you. If Michael can put into the chat if he has any. Yep, it seems like that answered it. So I have one more that I jotted down here, just sort of thinking about how this could be used sort of in a more automated or workflow fashion. And, certainly stop me or tell me if this is a crazy idea. But maybe in your previous life when you were at Delaware, did you use this to sort of set up, quote unquote, no-fly zones for maybe older operating systems or devices that that you wouldn't want to have coming into your network, let's say like an ancient version of Windows or something like that? Is it possible to set up automations with Zeek to sort of detect that something like that is coming online, and then either not hand out a DHCP address to it, or sort of wall it off so that it couldn't really use network services? Or is that sort of a little bit too advanced for just this use case?
Okay, there are two things. Zeke absolutely can alert on, and we had scripts that would alert us on old and ancient versions of operating system. The only thing that Zeke cannot right now do is, it's a passive monitoring system, right? So it cannot let the DHCP servers not assign that IP address, right? You need some kind of external communication or a out of band path going from your Zeke alert, in somehow saying or in somehow instructing or commanding the DHCP servers not to hand out that address. Haven't tried that, and I'm not sure whether it is even a capability that Zeke has right now. But we absolutely had this kind of monitoring where we would, if Zeke would see some kind of, just like the Windows 7 operating system kind of like went out of life beginning this year, we were getting so many alerts saying, okay, these are still like, a good bunch of people who are still using Windows 7 and they need to upgrade. So we did had alerts, but it was on us whether we want to, take how further we want to take the actions on. But I haven't, there's definitely scope of automation, but I'm not sure how much Zeke involvement would be there for the automation part, because as I said, Zeke is just, it just sits out of band of your network, and it just passively monitors your traffic. There has to be some kind of indication either written, or there might already be there that can integrate whatever Zeke is alerting on, that can back feed to DHCP servers, and then letting DHCP servers make a decision whether they have to assign an IP to that device that is connecting. But absolutely, that there's a scope of automation there, but I haven't seen it yet, and we didn't do that. We only took actions like manually. We would get an alert saying these 50 devices have very old operating system running on the device, and this is the list of MAC addresses. These are the owners. So it was up to us whether we want to like send out an email saying, hey, by the way, you have to upgrade your operating system. Another thing to think is like, how much do you want to annoy your users to do that? Because one thing that we were very careful of not like faculty and staff and professors, and especially like the VP or chancellor's offices, we see something on their network, we would be very critical of not bouncing them off of the network, because that would kind of like stop their critical operations of the day, and we would kind of like get a very angry email from the chancellor saying, you just kicked off the president from the network because of this automation. So one thing, it has to be very carefully planned, right? So that's another thing that in universities, it has to be very careful decision made, that how much automation you want to do on these kind of alerts, which kind of like are high priority or not high priority, depending on what the level of acceptance of risk you have in that organization. I know I just went too much away from the question, but does that answer the question, Jason?
Yeah, absolutely. I think that's fair, and I'm not sure if anybody else's mind went that way too. But we always sort of talk about how automation is really meant to help us in this community, and that's the first thing I thought of is, if there's this capability, how could it be integrated in? And certainly that's a great answer. The tool by itself does not have the ability, but if you can plug the hooks into other things, either to manipulate black hole routing or to play with the DHCP servers, it sounds like there's possibilities there, but certainly take them with a grain of salt.
Right. The tool itself doesn't have it right now, but yeah, we can, as automation experts, we can absolutely spin something off like that would automatically, take actions on these kind of alerts.
Okay. Well, we don't have any other questions right now, but I'll put out the call again. If anybody has any last questions, please type them in. And I'll thank you again for the talk. Really great. We'll make sure that we get the slides and the video of this one posted. And it looks like we may be done. So thanks again for everybody for joining this week. The next 2 weeks, we're going to be shifting and having some perf sonar topics for those that are interested in that. Both of them are from the University of Michigan, but it's going to be a couple of student intern projects. One of them, I believe, is measuring Wi-Fi performance, and the other, I believe, is small mobile perf sonar test units. I'll send out the announcement on the mailing list as usual. So hope everybody has a good weekend, and we'll talk to everybody soon.
Thanks, Jason. Thanks, everyone, for attending.